All right, guys, are there any questions over any of the assignments thus far? Any questions over any of the homework assignments y'all have had thus far? Any questions over the homework? Yes. Because what we're looking at today is the difference of perfect squares. So there's certain polynomials or certain quadratics that factor a certain way. Now these here, we can use the same steps we've been using to factor. The greatest common factor. And that's one thing we would always look for, is if there's a greatest common factor between the two terms. Then two sets of parentheses with three spaces. Then we'll check the sign. If the third term's positive, the signs are the same and match the sign of the middle term. If the third term's negative, the signs are opposite. Factors of the first and third term, and then check. And that works for pretty much all of these here. It still works for these difference of perfect squares. Now we call something the difference of perfect squares if we have two terms being subtracted from each other and both of them are perfect squares. Or we can rewrite it as a number or expression times itself. And it's going to come in the form of a plus b times a minus b when we factor it. So the difference of perfect squares is our a squared minus b squared would be a plus b times a minus b. So if we look at this example here, x squared minus 9, well, x squared is a perfect square because x times x. And as it kind of shows us, well, 9 is a perfect square because we can rewrite it as 3 times 3, or 3 squared, yes? So here our a is x and b is 3. So it factors a plus b times a minus b. So here it is x plus 3 times x minus 3. That's it. Let's look at an example where they don't have it completely written out for us. So if we look at this one here, x squared minus 25. Is x squared a perfect square? Well, yes, it's x times x. Is 25 a perfect square? Is there something that multiplied by itself that gives us 25? 5 and 5, yes? So this here is a difference of perfect squares. So one way we can look at this is we can say that we have x squared minus 5 squared. Because this is just kind of matching it up with the form a squared minus b squared is our a plus b times a minus b. This is just the definition of it. So for our example here, a is what? B is, so we'd have a plus b, yes? So that would be x plus 5 times x minus 5. And I believe we had this one yesterday also. And all the one of the ones we factored, we ended up getting x squared minus 25, worked out to be x plus 5 times x minus 5. That's it. These here are nice because they work in this pattern every single time. You ready for the next one? 4z squared minus 1. Is 4z squared a perfect square? What times itself is 4? What times itself is z squared? Z, well, yeah. So what we could say is that this is 2z squared, because 2z times 2z would be 4z squared. Minus, what times itself is 1? So this factors 2z, then our sign would be 1, and then 2z minus 1. Could we have put 2z minus 1 first? Yeah. Yeah, the order in which we put this really doesn't matter, because we could have 2z minus 1 times 2z plus 1. It'll be the same thing. Questions on this here? X squared minus 64. Well, x squared is a perfect square, yes? What's the perfect square of 64? 8. 8 times 8 is 64, yes? So how would this factor? We'd have what? X, 8, and x plus 8. Mm-hmm. Yes.
How do we get the minus and plus?
So we need the middle term to become 0. So the signs are going to be different. Also, if we were going through the steps like we would normally factor it, yes? 64 in this case would be the third term because we don't have our second term or middle term. If the sign of the third term is negative, our signs are and negative. Because if the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are positive and negative. They're opposite. But also, I'm multiplying two numbers together to get to negative 64, yes? Well, the only way I can multiply two things together and get a negative is if one of them is positive and one of them is, so we have to have opposite signs. Questions on this here? X squared minus 36. So 6 for 36 and x for x squared, yes? So how would this factor? Mm-hmm. And we could have done it the other way also. We could have said x plus 6 times x minus 6. Either one works.
Oh, so it doesn't matter how we put plus or a negative on this?
Because that's the nice thing with multiplication. It's commutative. I can multiply any two things in any order. Mm-hmm. No. As long as we do have the plus on one and minus on the other, then it's fine. Because this here wouldn't be x minus 6 times x minus 6. We can't have them both be the same. Any other questions on this here? 100 minus m squared. Well, 100 is a perfect square, yes?
Yep.
It's 10 and 10. M squared is m and m, yes? So how would this factor? Ten minus m times 10 plus m. Because which one came first? The 10, so it needs to go first. That's why we've been putting x first, or the number with the variable first, because it came first. Now, if you did flip it, don't write this down. Because if you said m plus 10 times m minus 10, this is technically half right. Because m plus 10 and 10 plus m plus 10 and 10 plus m are the same thing. Because we can add any two things in any order. But are these two here the same? No, because 10 minus m and m minus 10 can give us two different numbers. So if we said m is 11, so on the top one we would have, it would be nice to have the pin back, 10 minus 11 is negative 1. Here, 11 minus 10 is positive 1. Gives us different answers. If we wanted to get these two to match, well, forward, we'd have to say negative m plus 10 to get them to be the same. But I think it's a little bit easier just to keep it like this here. Questions on this here? Nine n squared minus 16. So 16 is 4 and 4. 9n squared is 3 and 3 and an n. So this would be what? Minus 4 and 3n plus 4. Now for these here, it is possible to have a greatest common factor we can factor out and do the same thing. And a lot of times, if we have two things being subtracted and we can't find a perfect square of either one, see if there's a number we can pull out to get it to work. So an example of this here could be 27x squared minus this here. Is there a number multiplied by itself that gives us 27? No. In 48, there's not one. But is there a common factor between 27 and 48? Because what times 3 is 27? And if we divide 48 by 3, 3 goes into 4 how many times? Once, which leaves us with 18. 18 divided by 3 is? Now do we have something that is a perfect square? Because now 9x squared is perfect square, yes? 16 is a perfect square. So we can say 3x minus 4 times. So sometimes there's perfect squares there. We just have to find the factor to pull out to make it so. And there's an easy way to check to make sure that some of these numbers, especially if we get to numbers like 169, 196, and going up past there, we can plug it into a calculator, take the square root of it, see if it is a perfect square, and go from there. And if the calculator gives you something, because for 27, and I would use the 30XS calculator, if you plug it in, it will tell you that this is 3 square root of 3. So it does have a perfect square, 3, but it also has an extra factor of 3. Because if we factor that out, it's going to give us the perfect square. And if you do the square root of 48, it'll tell you that it's 4 square root of 3. Both of them have an extra factor of 3 we have to pull out first. Kind of make sense? All right. This is the last part, because I feel like y'all feel comfortable with those there, yes? 54 squared minus 48 squared. We want to use the special product pattern. Well, our special product pattern stated that a squared minus b squared is a plus b times a minus b. Well, here our a and b are 54 and 48, yes? So we could say that we have 54 plus 48 times 54 minus 48. And we'll simplify from here. 54 plus 48 is going to be 2, carry the 1. 4 plus 5 is 9, plus 1 is 10. And then we would do 54 minus 48. 6. Because what do we need to add to 48 to get to 50? 2. Because if I add 2 to 48, I get to 50. How much more do I need to add from 50 to get to 54? 4 and 2 is? Then we just need to multiply these two together. 6 times 2 is 12. 6 times 0 is 0, plus 1 is 1. And 6 times 1 is 612. That's it. Come on. So, let's see here. So, 54 squared minus 48 squared. Just two numbers. 68 minus 62 squared. 780. Because if we did this by hand, it would be 68 plus 62 times 68 minus 62. 68 minus 62 is 6, 0. Carry the 1, so 130. 6 times 0 is 0. 6 times 3 is 18. 6 plus 1 is 7. Mm-hmm. Yep. Or we can just type the whole thing in the calculator.
Yeah, I also want to know how to work it out.
Yeah, and that's what's nice about this here is if we are having to find the difference of these numbers squared, we can do it by hand. And that's it. You all should have more than enough time to finish this up.